Welcome to Keystone Shooters, and today we're going to be talking about some introduction to differentiation. So before we begin differentiation, we must first establish what we mean by rate of change. So rate of change here, let's take y to be, let's say, our distance, and time and t to be our time. So A to B is time at point A, and we reach point B. This could also be x. So the rate of change is pretty much the distance over the time from point A to point B. So it would be slope, and then this would give us the slope of delta y over delta t. So then if we wanted to find a bit of a smaller rate of change, let's say between points little c and little d, we would just apply the same thing, finding delta y over delta t, but just for this time period of here. This is then when we are first introduced to the concept of differentiation. Differentiation, simply put, is just finding the rate of change at a singular point. So let's say A star being a specific point in time. So as you can see here, I've highlighted H representing the length or the width between C and D. At an instantaneous point in time, H is pretty much going towards zero, which pretty much represents that we are differentiating at that singular point in time. So if we were to compare this, when we can think of speed cameras, there's two types of speed cameras. We have the average and the instantaneous. So an average speed camera would be one of these here, where we start at point A, it measures our speed, and once we pass point B, it measures our average speed we were traveling across this time period. Whereas an instantaneous speed camera measures our speed at one specific point in time, which would be E star in this. So now let's apply this to our mathematical formula. So this is the mathematical formula for differentiation. F dash of x is equal to the limit as h goes towards zero of f of x plus h minus f of x all over h. You may be thinking, that doesn't make sense. When if h is zero, that would produce an error. You are correct in that fact. But that is important in this case because as you can see here, we're using the limit as h approaches zero, not h is equal to zero, because we can't, as it would in fact produce a mathematical error. Awesome. So now that we've established the formula, I think it's important for us to sort of ask why are we even finding differentiation? So there's multiple different fields and it spans across multiple different aspects of life, more than you would think at this current moment, actually. But let's keep it within a relative perspective, talk about ones which will be relevant to your high school career. So if you're studying physics, you would have probably already seen this in finding velocity. So differentiation is actually how we find velocity, which is a very important tool within physics for many different applications. Also, later on within your course, you'll be looking at differentiation in terms of optimization. So finding the point of local minimum or local maximum. So when we differentiate, find f dash of x, and we set f dash of x equal towards zero, it allows us to find the local minimum and or the local maximum. What do I mean by local minimum, local maximum? So if we look at this plot over here, the local minimum is the smallest point on the plot. So that x value, which we will find by rearranging the derivative and setting it equal to zero, that x value will be the lowest point on the plane. When we get into higher orders of differentiation, when we start taking into account x cubed, x to the power of 4, there might be local minimum and local maximum. There might be global, and this further and further. But for now, let's just think about, well, if we set it to zero, we can find local minimum and local maximum. Why is this important? Because let's take this into a real world perspective. Let's say you run a business and you make some chairs, and let's say you make them out of wood, for example. Obviously, as a business owner, you want to make as much profit as possible. So that would mean ordering the minimum amount of parts you would need to make the amount of chairs you want. not ordering too much and cutting into your profits, basically. So you would use differentiation and set this equal towards zero to find the minimum amount of supplies, X, amount of wood, which would be X in this case, you would need to actually make the sufficient amount of chairs you require. Okay, now that we've gone through the theory, let's go through a few worked examples. We'll go through two. First, I'm going to be using it in terms of this formula here. And then at the end, I'm going to go through these two quick examples again, and sort of show you a quicker method than using this formula here, because as you will see, it can be quite long and tedious. So let's go to the first one. We have f of x is equal to 2x. Okay, so we're starting off with this, and the question asks us to find the derivative f dash of x. So we go back to this formula and we say f of x plus h. What does that mean? Well, that is simply taking this and changing it to this. So as you can see here, where the x is, we replace it with a bracket and add x plus h. Awesome? Awesome. So we leave the 2 outside, and through simple multiplication, we find f of x plus h to equal to 2x plus 2h. Okay, so now we have f of x and we have f of x plus h. Let's use this formula to find the derivative. So f dash of x is equal to the limit as h approaches 0. Remember, not equals 0, approaches 0. So we have our f of x here. I might make that a bit more clear. So f of x plus h here, and we have our f of x here. Awesome. And then we will continue on. So as we can see, the 2x cancels with one another, and what remains is 2h on h. Simply, the h's cancel with one another, and the limit of h goes towards 0 of 2 is not necessary because 2 will always be 2. So as we can see here, the derivative of f of x of 2x is just equal to 2. Think about that and see if you can possibly see a pattern and what the quicker way might be. All right, we'll go on to a little bit more complicated, but not too much more complicated example. F of x equals 3x squared plus h. You may be thinking, wow, what are we going to do with the x plus h here? Simply, once again, we're just going to be putting in the x plus h into the x, but noting we keep the squared on the outside. What this will require us to do is do a multiply this with itself. All right, so simply we do, let's get a color here. We do x times x, x times h. Let's change colors here. H times x, and then h times h. Awesome. So x times x obviously is x squared, as seen here. X times h is hx. H times x is also the same as hx, so we just do 2hx to sort of simplify it. And then h times h is h squared, as can be seen here. And the 2 doesn't have any x associated with it, so we can just leave it as is. Awesome. So just expanding this out, 3x squared, 3 times 2 is 6, so we get 6hx. And then 3 times h squared is 3h squared. Awesome. So now let's go back to our formula. F dash of x equals the limit as h approaches 0. F of x plus h minus f of x all over h. So we plug that in here. So this is our f of x plus h. This is our f of x. As we can see, the 3x squared cancels here. 3x squared minus 3x squared is 0. And also, similarly, 2 minus 2 is simply equal to 0. So what we're left next is 6hx plus 3h squared over h. And reminder, h approaches 0. But before we apply this, let's see, can we cancel anything? Let's see. We can cancel h and h. Awesome. So what would that become? 6x. Also, we can cancel. I might make it a little bit more clear over here. Give me one moment. So we'll set the limit once again as per usual. So this is equal to, we'll keep that in the color blue, 6hx can be, just some notation sometimes easily confuses all of us. So just make it as clear as possible for all of you. because I remember being confused by some simple notation in my past and still to this day. So sometimes setting it up a little bit more can make a world of a difference. So what can we do? So we see 6h on x. Is there anything we can divide by? Obviously h on h. So what will remain? As we can see here, 6x. Awesome. And then the next, we have h squared on h. Simply get rid of the 1, because that's just h times h, and get rid of the h. And what will remain, as we can see here, 3h. Awesome. So now we have the limit as h approaches 0 of 6x plus 3h. Let's first break down the 6x. What happens to the 6x here? Well, what happens is it doesn't have a h term involved, so the limit doesn't even apply to it, so we can just take it out and leave a 6x. But it's 3 times h. What happens here? Well, as h approaches 0, the 3 will also go to 0. So we can sort of say that this whole thing here will equal to 0. So then we get 6x, and I'll make it once again just a little bit more clear, plus 0 is equal towards 6x. Awesome. So that is our second derivative finished. Once again, I will come to the top. Can we see a pattern of the original function and the derivative? So the original function was 3x squared plus 2, and our derivative was 6x. I'll leave you to think about it. If you want to pause the video and think about a possible quicker method before I show you, feel free. If not, we will get into the quicker method right now. All right, welcome back. So, what is this quicker method we are talking about? So the quicker method is f of x. I will just quickly show it in terms of numbers so you can apply it to anything, and then I will show it in terms of our two worked examples. So this is our original function. F of x equals a times x to the power of n plus b. Okay? So when we find the derivative, I should make that a little bit more clear. When we find the derivative, a, as it's associated with x, will just stay as it is. We will leave a as it is. And the next step is to take our n here, our n over here, and we want to bring it down to here. You see, from the original function to the derivative line, we've brought down the n. Awesome. But that does affect our n here. And all we do simply is do n to the power of minus 1. And I will let you know a little trick right now. If you ever have a function which is just a constant, so it's just a number, it could be 3, negative infinity, plus infinity, minus 400. Any function with just a number and no associated parameter, x in this case, the derivative of that will always be equal to 0. So as we can see here, b doesn't have an x associated with it, doesn't have a parameter that can change. So its derivative will always go to 0. So simply our derivative for ax to the power of n plus b is a times n, x to the power of n minus 1 plus 0. All right, awesome. So let's go on to the first example. So remember, our first example was 2 to the power of x. Before we begin, I want to highlight something to you guys. 2, before I said 2 to the power of x, that's meant to be 2 times x. So x is just equal x to the power of 1. All right? That's for everything. Time we just see an x, just think that's x to the power of 1. So let's go back to our quick method for derivatives. What is it? We have our x, and what we do, if we have a number in front, we keep that the same. So we'll keep the 2 the same here. That's our a. And here our n is 1. It's just 1 because it's 2 to the x, 2 times x. And as we said here, x is equal x to the power of 1. They're the same thing. So we're going to bring our 1 down here. Awesome. And then what we have to do, we have to do n minus 1. So 1 minus 1 is obviously just equal to 0. And anything to the power of 0 is equal to 1. So 2x to the power of 0 is equal to just 2 times 1. Let's make that a little bit more clear. 2 times 1, and that is simply just equal to 2. And let's confirm that with our original method, which we did. We had f of x is equal to 2x, expanded that out, and we eventually got it to 2. Awesome. So now let's apply this to our final worked example of the day. So we have f of x is equal to 3x squared plus 2. All right, so let's go back. What do we have to do? we have to bring the n down, and we have to take the power and minus 1. And if we have any constants, we have to make them equal towards 0. So here is f of x is equal to 3x squared plus 2, 3x squared to plus 2. Awesome. So 2 is our n here. And we have, what's this? This is just the 2. It might look like a z. Sorry about that. It is a 2. With no associated parameter, no x. So immediately we say that 2 is going to be gone, and it's represented here as our 0. So next, let's focus on the 3x squared. Simply, we bring the n down. So we bring the 2 down. 3 times 2, x to the power of 2 minus 1. 2 minus 1, 1. So we have 6 times x, and that is our derivative. Let's go back to our log method and see if this confirms. So f of x is equal to x plus squared. Doing the x plus h, we obtain this. Plugging it all into the formula we worked out is equal to 6x, which matches our thing. So thank you very much for watching. That is a quick little introduction to differentiation. We will be continuing this series on more differentiation principles, more and more so. I hope you have enjoyed this video, and best of luck with your studies.